Hello, everyone. Welcome to the August 2021 virtual meeting. And let's just get started. Welcome, everyone. Welcome, especially those of you who are new members. That's always cool when I see the monthly report and I see the new member list, and it's always growing, continuing to grow. There's always a few, which is cool. So here's a list of all the people that are serving on the executive board. I haven't checked lately as to who's on tonight. I know Trina's out in the Nebraska Star Party, but Matt's on. I know Matt's on. I'm on. So there's two of us, and I think Trina's going to join us from the remote Nebraska Sandhills. I think they're sandy. I don't know, maybe somebody else doesn't. I don't know if Baltz is on. I haven't seen him tonight.
I saw Conrad briefly.
Oh, Conrad he blinked. And Gunnar. I updated this slide, so now everybody's got a name to go with their picture. So that's even cooler. Always trying to make improvements.
I'm here, Mark.
Hi, Conrad. Good.
Hello.
Awesome. So thank you, volunteers. Thank you. This club would not operate very well without volunteers. As any new members that are on tonight, welcome. And just know that there are no paid positions within the club, so everybody's a volunteer, and that's how things get done. We have work parties. There have been work parties at ELO and LLCC. I don't think there's been any serious work parties at CGO the last month, but thank you to all of those, because I mean that work that's being done, that's upkeep, that's maintenance, that's installation of new things, that's getting ready for events. Events at LLCC, events at ELO, and then that's just how things get done. There's continued work being done on the MAS website to update that. I think we're a little bit away yet from a public release, and then we'll get there. And then there's the volunteers that are prepping for NNSF and Camping with the Stars. Those events don't happen automatically. It takes them a lot of work behind the scenes. And then there's the star parties that the public star parties I'm talking about at ELO. There's volunteers that show up there. There's volunteers that go out there and sweep and clean and take out cobwebs. And there's people that show up also just to tend to the public on those nights. So thank you.
Yeah. And if I could interject, I think they did have quite a bit going on at CGO. You might have mentioned it last month. I wasn't there.
We did mention it last month. That's
excellent.
That was last month.
Gotcha. Thank you.
Yep. And then just a reminder that the listserv has been discontinued. So any email that you have been using or were using that was related to lists, that had list in the name, those no longer work. And here's a list of the new ones. I was informed that there wasn't a very clear link to the Gemini article editors, so I included that on this slide so that then it gets in there. So refer to this. I think the only way you can get to this is this particular list all in one place is on this slide. Which then winds up being part of the video that gets posted. But if you go on our website, you certainly can ferret out some of these email addresses, and that way you can contact whoever you're looking for appropriately that way.
I've got a question. Some of the websites, like I know CGO had one, and then not sure about LLCC, but it was kind of a monitored one where the email went through, but it had to be cleared before it actually got to that mailbox.
Yeah, I don't think that happens anymore. That was part of the listserv.
Okay.
because now these are, in the background, in the, behind the curtain, these are Google email addresses.
Yeah, and they go to a distribution list of some sort.
Exactly.
Gotcha.
More secure, making sure, just try to minimize the spam and the people that are trying to break in and cause pain. And then another reminder of that collaboration tool, Slack. It's pretty cool. I enjoy it. Now I realize I'm probably a minority, but I kind of enjoy the chatter that's on there. And there's separate channels, and the administrators of that monitor that some of that chatter. And if it gets too much into one subject, we just created a weather channel just recently because there's a lot of people talking about the weather in one of the channels. So we created a new channel called the weather. And I personally have created a couple of private ones where it was just a small group of us. We we're discussing something and didn't think it needed to be that public. And if we thought that it eventually grew to that, we could have made it public. But it's really cool. I've used the text chat. I've used the audio part. I've used the video part. The video part works quite cool. It works if you've ever used, even like Zoom. You could invite several people and have a video conference using the Slack tool. So I recommend it. It's not to replace anything. It's just another tool. It's just another way to communicate. The board uses it almost exclusively to do business. And I know that there's a channel set up for each of the sites. I don't know how much they use it. I haven't monitored that. I did look at stats. I saw there's like 75 or between 75 and 80 people actually registered and signed up. And I kind of looked at usage, and it's somewhere around that. It has its highs and lows, depends upon what's going on. If it's clear, I think there's more chatter. So it's cool. Check it out.
One note about that, Mark, is we do verify MAS membership when you're requesting to join. So
that's right. Yep, this is for members only. So, and everybody's name is your name. I don't think there's any handles. So
that's preferred, yeah.
It is preferred. Yes, we prefer that because we like to know who we're talking to. And just a reminder, we are on YouTube. And if you have trouble finding it, because this is kind of a long URL, I did a little thing today. I just went in and typed in Minnesota Astronomical Society in a search, in a browser search, and it takes you right there. If you do MAS, it doesn't work so well. You wind up with a few things that nothing bad. It's just not what you're looking for. And I guess when I refined it and spelled out everything, it worked great. So that's where our monthly meeting is posted, the video, because as everybody knows, this is being recorded, and we do a little process on it, and then YouTube does a little process on it, make sure we don't have anything in there, use any music or anything like that we're not supposed to use, and then they eventually will release it too. So. Anton, are you on tonight?
I am here.
There we go. It's Lunar Scope program talking time.
Yes, and as always, members can request our lunar scopes. We have 14 in service right now: SCTs, Dobbs, refractors, and a solar scope. We've had 47 loans so far this year. Members can request these telescopes under our website under members lunar scope program. Also on that same page is a list of our 14 short courses on astrophysics and astronomy, those great courses. So they can request any of those through the website, and the complete list of those courses is also available in the Gemini. So again, if you want to borrow a telescope, just send me a message through the website and I will do my best to meet your request.
Awesome. Thank you. Thank you, Anton. And if anybody's on the call that has a question about something, feel free to just jump in. I'll give you a couple seconds. Okay, I'm gonna move on. So things that are going to happen, before our next meeting, as I like to put it. Actually, I missed one. I didn't have this in. I didn't realize Saturn was that close to opposition already, and I missed it. But it happened already this week on Monday. It's New Moon weekend coming up. Everybody gets excited about New Moon weekend.
Hey, Mark.
Yes.
Can you explain what Saturn at opposition means to us that like to look at Saturn?
I'll do that when I get through with
Excellent.
get down to Jupiter.
Good.
Because it's the same thing. And then the moon is going to be close to Venus, or Venus is going to be close to the moon. I guess the moon is going to pass by Venus, kind of close. It's not really close. It's just easy to identify that that's Venus when the moon is there, and that'll be in the evening coming up next week on Wednesday. And then it's the Perseid shower. They say every year that it occurs around new moon, they say, oh yeah, this is going to be the year. So maybe this is the year. And I understand that you have to see the most meteors, you have to be in a very dark sky. So get out of town, get in a dark place, allow yourself to adapt to your night vision, get your night vision going. And, you just have to wait. And, it's, they talk about the Perseids, it's Perseus. That's where the radiant is. That's where the meteors will appear to come from. And that's, you don't necessarily have to look right at Perseus, the constellation. You can look, I always like to think, look the other way, 180 degrees the other way, and watch them, stream from the zenith away from Perseus. I think you probably can see more. That seeing them straight on, I guess I've tried it, and I think I have better luck the other way. So check it out, try it. Hopefully it's clear. That's next Thursday, Friday. You gotta wait till that moon goes down. More than likely, you gotta wait till after midnight anyway, for the Earth and us to be facing that direction as to where they're coming from. So check it out. And then look how close Mars and Mercury are together. I don't know how challenging it was. I didn't take the time today to look at a planetarium program to see how close, not how close they are, but how close, how high in the sky are they going to be. I can't imagine it's very high because Mercury's never very high, but I imagine that, a pair of binoculars, you'd probably be able to catch that. And then Jupiter's at opposition. So to answer Matt's question, that just means that if you're looking, if you know where the sun is going to be opposite of where Saturn or Jupiter are going to be, meaning that that Earth essentially is going to be right in the middle, or a line of sight between the sun and the planet, between sun and Saturn, between the sun and Jupiter. And what that means is, as the sun sets, these planets rise. So then around midnight or so, they get at a decent altitude to where you can look at them quite well, and enjoy them. Because
and they'll be due south at that time.
Right, exactly, yes. Around midnight or so, yes.
And they're as big as they get in our view on an annual basis, right? In their orbit, they're closest.
Yeah, we're as close to them as those planets as we're going to be. and even though we missed opposition to Saturn by a couple of days, we haven't moved that far away from it, so to speak. If you were thinking about it,
yeah, it's not a sudden change. But it is nice because it's as big in the view. You can see more detail and that kind of stuff.
you bet. And then there's the full moon on August 22nd. And then our next meeting on September 2nd, which I'm thinking is definitely going to be virtual. And if my plan works out, I'll be running that meeting from NNSF. I just haven't finalized my plan as to whether I'm going to be there. I'm about 90% there.
Is there a subject for the August or the September 2nd meeting or a speaker?
Yes, there is. Someone from the U. August star parties. So we have the Camping with the Stars, August 13th through the 15th. There's ELO Star Party, August 28th. The Beginners Special Interest Group has a star party August 27th. That's a Friday. And then there's Northern Nights. That is open to the public. Don't necessarily have to be a member. That's right, Ken, right? You don't have to be a member.
That's correct.
And so very exciting for at least the public stuff. And there's a lot of things going on this month. And then there's the regular star parties. There's one this weekend at LLCC. I hope the weather cooperates. And then there's one also at CGO. And then another star party at LLCC August 13th and 14th.
So I got a question for people. I've been in New Mexico here for a few weeks, but I've been hearing reports about smoke in Minnesota. Has that been affecting your star parties?
Yes.
Yes, absolutely.
I would think it would be devastating. So I'm surprised you're even trying.
We're day drinking, Gibson. It helps.
Yeah.
Planets are still good.
Yeah, I mean, there's things to see. I mean, we don't have a choice. We don't have any control over it, so we'll take what we get. A clear night under a dark sky. I'll take that over a cloudy night and having to go to bed early. So Camping with the Stars. Merle, I don't know if you're on or not, but I did prepare a couple slides. I do have the schedule. I don't know if there's anything particular that you want to talk about, but I have the schedule. Friday night, observatory opens at 7 p.m., basically with solar and planetary viewing. There's also a speaker that's going to start at 7. Doug Neverman's going to do a survey of astrophotography, and then around 10, weather permitting, if it's clear, there'll be a constellation tour. Hopefully there's no smoke, because here's the other night I was out and it was smoky, and and even from my backyard, which is usually pretty decent, I could see the Milky Way. I could only see 4 stars of Cygnus. I was very upset. And then Saturday, observatory opens at 2, and the first speaker is at 3. Colin Coulain always has fun with the kids, with some take-home activities. Not so excited about the slime, but the catapults. I mean, wow. To throw a little stone a little ways. That's be kind of fun. And then 4 p.m., Michael Copper is going to bring make your own planisphere. And later on, then he'll even show you how to use it once it gets dark. And then there's an opening for a speaker at 7. And so if there's someone in this audience, you can contact Lila, and she can be reached through the outreach email address on the website, and talk to her about that, and she'll get you set up if you're interested in speaking. And then there's the big raffle prize. I mean, 6-inch Dob. And then I heard there's a lot of other things. There's a few other things going to be given away. MAS merchandise, always a big draw, I know. And that drawing is at 8 p.m. and you must be present to win. And then there's a at 10 p.m. again, a Constellation tour. Merle, you on? You have anything to add?
Oh, yes, I do.
Okay, add away.
Don't forget the door prize drawing.
I thought that's what this is.
Nope, raffle and a door prize.
Raffle. So what's the door prize then?
Door prize will be binoculars. I think we have a pair of Celestron binoculars as the grand prize there, and a Star Blast as well for the door prize.
The door prize. Is that a 4-inch, 4.5 inch?
4.5, I believe.
Yeah. At the Orion one?
Yes.
That's a treat.
Yes. Now, we still have, I just got the list of participants from Connie at Baylor Park, and all of the campsites in the park are full. But as of now, there are no campsites in the ball field reserved. So we have the potential to have 30 or 40, tents set up in the ball field. To do that, of course, if you want to come out and camp, just need to call the park office, and there's a fee for this event. But that fee gets you into the door prize drawing. So that's what the fee is covering, and the help from the campground in the park. Okay.
Do they let you drive on the ball field set up?
Yeah, I mean, it's happened before in the past, and they haven't scolded us for that. I would stay off the ball field if it was saturated with rain, but it's as dry as concrete right now, so I think we're okay.
Yeah, if it's anything like my lawn,
Yeah.
you're not gonna hurt anything. They kill the weeds, maybe. Anything else, Merle? You have enough volunteers?
Hey, Merle, Steve here. I just looked in the chat and Earl said to everyone, we were told no ball field camping. Any idea what he's up about that?
Earl.
Yeah, Earl, you want to unmute and see where you heard that from?
I just made reservations, I think yesterday, and got one of the last camping spots, primitive camping. And she said they're not taking reservations for campsites on the ball field.
Well, that's interesting. I've never heard that. Do you know who you talked to?
Why?
Do you know who you talked to?
I didn't get a name.
Okay. I will call them again tomorrow and see what the problem is.
Yeah, that might explain
yeah.
why nobody is on there.
Okay, I will find out. At the very least, I'll post on the forums what I find out.
Yeah, send me an email to Merle and then I'll post it on Slack.
Okay. But I think that's all I have for Camping with the Stars. Oh, wait a minute. I haven't just said that. I have one more thing. We are changing things up again a little bit because of the COVID restrictions, et cetera, et cetera. So if you haven't seen the COVID rules, want to make sure you review those. The link is on the homepage for the public events. Primarily, it's the fact that we're still wearing masks at the observatory, inside the observatory, and at telescopes on the plaza. So that's the big thing. So any presentations that may happen in the classroom will be masking. And again, anybody in the observatory buildings will be required to wear a mask. For our cookout on Saturday afternoon, again, part of the registration fee, we are going to provide the burgers and buns and condiments, but we're going to try to limit any of the shared dishes. Whereas we in years past, it had been a potluck and somebody would bring a dish and we'd share that. We're not going to do that this year. So if you want to bring a side dish or a bag of chips or something, you're on your own for that. But we will have burgers and brats and things like that. And then the Sunday brunch, where we had gotten it to be almost a full buffet a couple of years ago. We're just going to have coffee and donuts, but we will have a little morning snack for the campers that are still there. And that's all I've got.
All right, thank you, Merle. So hey, it's a fun time. First quarter moon. So Ken, here's your slide.
All right, Northern Nights Starfest coming up September 1 through 6. Registration's open. You can find a link for it right there on the slide here, but it's also on the MAS site. Currently, for speakers, Saturday night, we've got Bob King, also known as Astro Bob. He's going to be talking about Andromeda and how to see stars 2.5 million light years away. John is working on getting someone from the U of M for Friday night. Thursday night, we may have a live MAS meeting up there.
Oh, yes.
During the day, Jerry Jones is going to be talking about Pickering's computers, about the nature of astronomy in the turn of the 1900s and how women made tremendous contributions to our understanding of stellar classifications and the distance determination. Dick Jacobson is going to talk about his 30-inch telescope projects and some wide field binoculars. Dave Faulkner is going to talk. I guess I don't know what Dave's topic is.
I'm going to be talking about the Juno mission at Jupiter.
Okay. And we're still probably working on getting a few more daytime lectures still. So hopefully it'll be a good time this year. They are just opening up there, so we'll be one of the first groups there. If anybody has any questions, go ahead and ask. All right, I guess not. Right now, I guess we have 28 people signed up right now, from what I understand.
Cool, that's great, Ken. So Ken, you probably can get a hold of Ken through the website and contacting the LLCC link that's on there. That'll definitely get you to Ken eventually.
Yep, we have a lot of good door prizes too.
Oh, yeah,
what's the capacity for the place?
Well, we've always figured that, with the size of the observing field and stuff like that, we could handle a max of 50 people maybe. But, with the rooms and stuff, we 4 people per room max. You can probably fit, like 70 people in the whole facility or whatever. But we always figure max around 50. I think the most we've ever had is just over 40.
Cool. Thank you, Ken. Oh, so hey, Merle, here's my slide about COVID. But let me just talk about that for a little bit. Help us. I mean, and help everybody else is get your vaccination if you're eligible. I mean, I'm not saying it to start with something political. I'm saying that I'm confident that it works, and that's just my personal opinion. But the board, the way we have it set up, and it's pretty much the way Merle just laid it out, is that there's requirements for masks for public star parties, and that's the way it is. We want to protect our volunteers who have young children, because they can't get vaccinated, even though most of the people that are showing up, and science is telling us that just because you have been vaccinated, you can still be a carrier, especially this Delta thing. And Sure, kids are resilient. Sure, they bounce back, but what are the long-term effects of kids getting sick? They're young. They have a lot of their life left. And it would be terrible if one of them got sick and it had a lasting effect. So let's help them out, because they're our future. They're the ones that are going to be taking care of us when we are senile. I'm speaking for myself. And then the other thing is and I guess that's probably my next slide, is that tomorrow, or I mean not tomorrow, but Saturday is the astrophotography workshop. We're requiring masks for that also, and it's being held inside the classroom, and so it's masks for everybody. But I guess my next slide is the beginner's special interest group. And if Suresh is on, he can maybe speak to this. The only thing I know is that it's at Metcalf Field. It's August 27th. It's going to start around 8 o'clock. There's no power. And I should have put a little thing in parentheses there. Give us a little bit. We're working on that. We got to work out some details. We'll figure it out. Power will be coming back to Metcalf Field sometime in the future. Okay, next slide. Maybe. So there is my public service announcement for the astrophotography. Mike Shaw is going to be doing a couple presentations in the afternoon, and I am actually going to be doing a presentation in the evening. And we are at capacity. We actually have a waiting list for any cancellations, which is getting kind of short now. So I don't know that there will be too many changes to that. But there again, just anybody that's on that is planning to go. I know we've been pretty proactive about promoting it and sending emails out to keep everybody abreast. Masks are being asked that you wear a mask inside the building, because we're stuffing 50 people in there, so that'll be close. It'll be close quarters. So thank you. And then another month, another call for Gemini articles. Whatever you're doing. I just read the latest Gemini that just came out the early part of this month. Another fantastic issue. Lots of interesting things. This is a club that's run by membership. It's also the same way it goes for the Gemini articles. It's you guys that produce these articles. It's great. I find it very interesting. And if you got something that somewhere you've been, something you've built, something you've seen, Father Brown, it doesn't matter how long or how short, he'll figure out a way to get you in the issue. So, if there's any questions, you can contact that email address, gemini@mnastro.org. Jerry Jones, are you on? It's showtime.
I am on. Hi, everybody.
Okay. I have to stop sharing my screen.
All right.
Stop share. All right, Jerry Jones, the floor is yours.
And somebody's going to have to remind me, oh, this is how I share my screen. Can you guys see this?
Yes.
Beautiful. Good job.
And if I get rid of this.
Oh, we didn't see that.
Okay, so how do I tell me how I get rid of the little box on the top that's in the way of my I got a box right up here. Anybody tell me how to get rid of that? Nobody tell me how to do it? Okay, that may be a little bit of a problem. I'll figure it out. Good. It went away. So thank you, whoever did that to me. So hi, everybody. So this presentation, this Better Know a Constellation, is entitled The Summer Underdogs, or the Underdogs of the Summer. And instead of because I really kind of see this whole better known constellation as an observer more than anything else. I see these three, actually four constellations, as a unit, as part of the sky. And so I thought, well, what the heck? I will change it to better know a constellations. And I hope, and somebody's gonna have to stop me if I go too long, because there's a fair amount of stuff here. I want to share with you Vulpecula, Sagitta, Delphinus, and Equus, if we get to it. So Vulpecula, Sagitta, Delphinus, and Equus. Now these four constellations are really pretty small, but they all kind of fit within the same portion of the sky. So again, as an observer, I kind of see them all together. So let's start with the biggest one, well, at least in the picture anyway. And now I'm going to get rid of, yes, I can. I'm going to get rid of the mythicals. There we go. And now we just see these are the lines. This is a fox. Can you see it? There it is. Yep, you can see it there. There are the two little eyes and the tail, and right, sure. So this is a constellation that has no mythology. It was given, it was created by Johannes Helvelius in the late 1700s. He called it, originally he called it Vulpecula Enser, little fox with goose. And the goose is right there. You can see it plain as day. There's the goose. But now it's just known as Vulpecula. And if I'm not mistaken, this is the alpha. Yep. And so instead of having a goose, we have a star, which is called goose, which is what answer means. So it's like so many of these constellations, it looks nothing like what it's supposed to, but that's the way it goes. Vulpecula isn't known for a lot of amazing things. It's the 55th out of 88th of size wise, but the first pulsar, unfortunately, I can't tell you where it is. I looked for it and I couldn't find it. The first pulsar was discovered in this constellation. And this was long before pulsars knew. Of course, pulsar generates a very consistent and specific electromagnetic frequency. And so they found this thing in the sky that was sending out this very, very consistent rhythm of a frequency. And it first was called LGM1. That was its name, which stood for Little Green Men. They weren't sure, but they thought maybe this had something to do with extraterrestrial intelligence, but it didn't. So this is Vulpecula. So Vulpecula's got a few goodies in it. Although before I jump into Vulpecula, I really need to share. I want to make sure I remind everyone, if you're looking at this part of the sky, you got to look at Albireo. It has nothing to do with Vulpecula, but it is such a beautiful double. It's splittable with a pair of binoculars, with a small telescope. It is so gorgeous. The color. If anybody asks you, oh, there's no color in the stars, take a look at this. Show them Albireo, and the colors are so magnificent. I'm not going to tell you what they are. Make you go look for it yourself. The first thing we're going to take a look at, and it doesn't show up here, so I'm going to go grab it, is Stock 1, which is a fairly open cluster. There it is. It's a fairly open cluster. It's really a binocular object or a finder scope object. It's a fairly open cluster. As you can see, it's got kind of a W of stars here. It's really worth going after. And it's just kind of a very pretty one. I'm going to move pretty fast here, so I'm hoping that you guys will kind of go, oh, that's cool. Oh, yeah, that's cool. Oh yeah, I'd like to look at that. That'd be kind of your attitude towards all of this. We're going to scoot down here to probably the most famous asterism in the sky, which is the coat hanger, also known as CR 399 and also known as Brocchi's cluster. It's a cluster of 3.59 mag, 4,200 light years away. It was actually has been known for a very long time, but Persian astronomer specified it in the first century. It's been known as Brocchi's cluster since the 1920s. Who was an AAVSO star maker, so he wrote his name down on it, and it stuck. But it's really a pretty one. That's something you just got to look at if you're in that part of this neck of the sky, and you just are looking around. You got to look at their coat hanger. It's just a real pleasant one. Right off to the side of the coat hanger is another cluster, NGC 6802. It's much smaller, of course. It's an 8.8 mag, 5,800 light years away. It's only about 5 minutes, and you can see by zooming in here. And let me take a second. I almost forgot. I got so excited about sharing this stuff in the sky with you. I forgot to share with you a little bit of, and a thank you to Simulation Curriculum, which is a Minnesota company, and Mike Goodman in particular. The last month I wrote to them and asked them, because I was using a different type of Sky Safari on my Mac. It wasn't working terribly well. You might remember that from last month. And I asked them if they would be kind enough to help out MAS and provide a Starry Night Pro, and they said they would, and they did. And so this is their Starry Night Pro 6 that I'm using, which is so very kind of them. So thank you to that, and Mike Goodman. But I also want to share with you that it's a Minnesota company, and they really like supporting us as Minnesota astronomers. So they are offering a 25% off upgrade price to either Starry Night Pro or any of the Pro Plus upgrades, and that's at their store. And the code for those of you, and we'll try to throw this on the forum somewhere. The code at their store is MN. MN is capitalized. MN Astro 21. So that's pretty cool. It's nice when vendors like that will give us a bit of a discount. And also, Michael wanted me to let you know that Sky Safari 7. I know many of us use Sky Safari on our iPads, our tablets to run computers. Sky Safari 7 is coming out on September 15th, and for a month it will be 50% off. So now back to our regularly scheduled program.
I got a quick question for you, Jerry.
Yes, sir.
You said that the upgrade was 25% off. If you don't have it on your computer, can you install it? Is it like new?
My understanding is it is the upgrade.
Okay.
The cost of the upgrade is 25% off. That's
Gotcha.
my understanding. That's right, straight out of the email from Michael Goodman. Okay, back to our regularly scheduled program. So this is the one at the edge. Yep, I remember correctly. So if you're looking at, especially if you've got a telescope, if you're looking at the coat hanger, you need to take a look at this one. There's not a whole lot to it, but it's certainly worth knowing that it's there. The next one is NGC 6823. So what we're going to find out, because we are so much in the 6823, because we are so much in the Milky Way, there are just tons of open clusters. And we pull back, we can see what the Milky Way looks like. I have it on just the line, and this is the Milky Way along here. So actually we're in the middle of the Great Rift right here. This is the dark space, the dark nebula, huge dark nebula you could call it. So right in the midst of all this is a pretty interesting open cluster, and it has a kind of a strange, fairly obvious shape right in here. So that's pretty fun to try to find. It is supposedly within a reflection nebula. I couldn't see it here in Stillwater. Likely you could probably see it in a much darker sky, but this one I couldn't see. 6830 is our next animal, and again it's another open cluster, not too terribly far away. And this one has a very cool V in it. Around the kind of the southeast corner. And what's fun about some of these open clusters is if you sit and look at them for a while, you start to see interesting asterisms. You start to see cool doubles in them. You start to see interesting looking triangles and rhombi and all of that kind of stuff. And they're fun to sketch in the sense that the more you sketch, the more that you see. Well, now we're going to go to perhaps the most infamous member of Vulpecula, which is the Great Dumbbell Nebula, M27, which is right here, and this is where it sits. So we're just off of the edge of Vulpecula here. And again, this is another one of those things, boy, if you haven't looked at it, and I know that the smoke has been so unpleasant. I'm not sure if it was Bernie from calling in from Arizona. And yes, the smoke, as a relatively avid visual observer, the smoke has been a challenge this month. It is what it is. As Mark said, we don't have a lot of control over it, so we hike up our skirts and we enjoy what we can enjoy. This is so worth looking at, even if you have to look at it through a bit of smoke. It's so worth looking for. William Herschel found it in 1764, and his son John gave it the name. So that's kind of cool. Now there is over in this neck of the woods, although I think I'm probably going to need to call it in, is a double cluster, 6882. There it is. Oh, it's up this way. And there really are two of them, 6882 and 6885. Now again, I'll back out a little bit so you can see what's going on, where that sits. There's the dumbbell stock is over here. Here's the coat hanger. These two are also known as Caldwell 37. So that's kind of neat. It's a Caldwell object, and they're two clusters that are combined, and the smaller one has a beautiful red giant right in the center, and this one has a very brilliant blue giant. So in some ways it's fun to find the clusters, but it's really fun to just see what's inside of these things. And then I'm going to kind of scoot ahead over here. I believe is Rosalind 4. Yes, it is. Rosalind 4 is a small cluster, but what's cool about Rosalind 4 is that's embedded in a reflection nebula, but also I was able to see this from a couple nights ago when we had a good night, maybe a week ago, we had a good night. I went through all of these and looked at all of these, and I was actually able to see this reflection nebula, and I was able to see it without any filters. And in fact, I found that filters didn't help much. So Rosalind 4 is a small one, but if you've got some even decent skies, you should be able to see the nebula. So that's kind of a twofer in so many ways. There are some carbon stars, but I'm going to scoot ahead. I have no idea how much time I'm taking, but I need to scoot ahead to this next one, which looks surprisingly like what it really is. It looks like an arrow, and in fact, that's what it was considered, and so it does have some mythology. It's a pretty small one. It was included in Ptolemy's list of 48 constellations. Supposedly, it was the arrow, at least this is one of the stories, the arrow that Hercules used to kill the eagle, the Aquila, the eagle, which is down here. That's this guy right over here. Here's the eagle, Aquila the eagle, to kill him, who was perpetually gnawing Prometheus's liver. Oh, what a good time. So Prometheus no longer, he got freed, Hercules freed him, and he didn't have this eagle. What a mean thing for that eagle to do, to be chawing away at Prometheus's liver, and he used this arrow to kill the Boyd. So good for Hercules. Interestingly enough, in Chinese uranography, these stars are part of what's called the black tortoise of the north. And in fact, most of these in this area were called the black tortoise of the north. I tried to find a picture of the black tortoise and I was unable to do so. So Sagitta's got a few goodies, but there's a couple of double stars. This one right here, I believe this is Theta. Did I get it right? I did indeed. It's a beautiful double. It's got some color. There's a couple of red giants. I think it's this one right over here. X Sagitta. Nope, it's in this variation. In this area. I don't want to spend too much time with you guys because we've got other things to do tonight. So if you were to, but there's some beautiful carbon stars. You want to take a look at these. Carbon stars are so great because when you're looking for a carbon star, and the two carbon stars in here are X SGE, Sagitta, and BF SGE. So if you're taking notes, heaven forbid that you would consider doing that, you want to take a look at these two carbon stars because they will just jump right out at you. You get them in the eyepiece and you go, yep, there it is. And that's always kind of fun. So these two
Jerry,
carbon
is there a
stars,
list where we can find those?
carbon stars?
Yes.
Yes, you can go to the good calls, Mark. Thank you. The Astronomical League has a observing list of carbon stars. And you can get that list off of the website. Unfortunately, some carbon stars don't look red, and it was frustrating for me when I did the list. But these two, X and BF, they just stick out like sore thumbs, and it's good stuff. There are two clusters that I want to focus on, then I'm going to move on, and one of them is Harvard 20. It's a fairly small 7.7 meg, only 7 minutes. It's a fairly nice open cluster, somewhat aligned. You can see there's kind of a line right here and a line right here. And what's neat about this is because if you're looking in a wide field telescope, you're going to get two for your buck here. And this is M71, which is a really interesting and cool glob. It's fairly loose. And so if you've got a decent night and you've got a telescope with some good resolution, you can resolve it all the way down to the core. And that's somewhat unusual for a globular cluster. So it's a fairly loose one. I think it's like maybe in the Shapley Sawyer 10 or 11, but I neglected to look that up. Okay, so that's Sagitta. We're going to move down to, in this whole lineup, down to the Delphin. Now, the Delphin actually you can imagine that's what it looks like. And if I go back over here and turn on the Mythical, you can see it. There it is. I have to back out a little. There it is. You can see it. Yeah, it looks like it. Yeah, you can kind of imagine it's a Delphin. Oh, sorry about that. Let me turn it off because they kind of get in the way. There we go. So it does have a little bit of history to it. It was it's another love triangle between Poseidon and Aphrodite, and wanted to protect herself because everybody wants to protect themselves from Poseidon. Delphinus finds her in this story and convinces her to let Poseidon woo her. So Poseidon said, "Hey, nice job. I'm going to toss you into the sky," and there you are. I think that there are also a few other stories of the Greek and Roman mythology. This, however, is also part of the Chinese black tortoise of the north. It does have a main asterism. These 4 stars are also called Jacob's coffin. I have no idea who Jacob is or was. What's kind of funny about this star, you see these 2 names right here? Goofy names. These 2 goofy names, Swalowkin and Rotanev. Well, this constellation was placed in the Palermo star catalog of 1814 by Niccolo Cassiatore, and he named Alpha and Beta for one of the guys who worked in his observatory, and his name was Nicholas Venator. And yep, you can see it. There's Nicholas, and there's Venator backwards. How's that? And because it was 1814 and he was doing a catalog, the names have stuck. So there you go. Crazy reasons for crazy names. The Delphinus has a lovely double star right here, which I want to highlight for a second. And also, I want to highlight, is this the one? Nope, that's a different one, sorry. But this is a lovely double, and it's easily split. There's a very cool double, I think it's in Sagati, that has a red giant next to it. That's another cool thing about many of these sets of stars. You find all sorts of different colors, and that's kind of half the fun. So that's a beautiful double that's got some color to it. So that's kind of fun. There's a planetary nebulae that stands out, and that is 6891. I'll show you where that one is, 6891. It's way down over here. Planetary nebulae actually do fairly good in less than perfect skies because they typically have this bluish greenish color to them. And so if you're looking at a field of view that has a planetary nebula in it, and there's something, even if it doesn't have a non-stellar shape, you can often figure out, oh, I bet that's it, just because of the fact that it doesn't look quite the same color of everything else. So actually the planetary nebulae are okay game for when we don't have less than perfect size, at least the large ones in particular. There are two globs, which is very cool. One of the globs I'm going to send to you to right now. One of the globs is 6394, but I'm going to clip that one and I'm going to go to 7001. Nope. NGC 7001. No, 7006, my apologies. Haha, nope. 7006, or NGC. There it is. So this is a beautiful glob. It's dimmer, it's very tight. And so it's as you can see even from this picture, it's particularly cool to take a look at. But one of the things I wanted to do rather quickly is just show you a little bit of what you can do with this cool program. Is it has what's called a galaxy view, and I wanted just to share that with you. If you take a look at this, this is cool. Here's our sun, and this is where NGC 7006 is. Oh my word, look how far away it is. It's in fact 130,000 light years away from the center. And if you take a look here, let me pull this out a little bit. And so all of the stars you've been looking at are in this area, are right in this particular area here. And I can show you where the constellations are. See, here's Cygnus, here's Aquila, so that's where the constellations are winding up. But look how far away it is. Oh my word, it's way out there. It is so far away. So it's one of the cool things about looking at this particular globular cluster is when you find it, you're looking at one of the farthest away things that is connected to our Milky Way. It's at least in the northern hemisphere. It's just very, very cool. All right, so the final underdog, which will be the easiest one, is Eccus. There it is. And it does have a little bit of mythology. It's part of Ptolemy's 48. It was either Pegasus, and of course Pegasus is over here. Here's Pegasus, way over here. It was Pegasus. It's either Pegasus's offspring or Pegasus's brother. So it's kind of hard to know. Hopefully it's not both. That'd be kind of weird. But it is known also as Ichthys Prime because it rises sooner than does Pegasus. So that's pretty cool. Now, what does Ichthys have to show for us? Really not much. So the last thing I want to tell you is that I'm going to hawk this book one last time because all of these objects I pulled out of a book called The Objects in the Heavens, which again, I find is such a great book to have in your back pocket as you're out observing. Because if you've got an 8-inch telescope, or maybe a little larger or maybe a little smaller, and you're looking at a constellation and you want to ask, what can I see with my equipment? This book will give you the stuff that you can see. And I like that. I really appreciate that about this book. It's good for beginners, and it also has some stuff for people like me who have spent a few hours under the skies. So there you go. There are the underdogs of the summer constellations: Vulpecula, Sagitta, Delphinus, and Ichthys. Which Ichthys, by the way, out of the 88 constellations, can you guess what size it is? Highest to lowest, largest to smallest. And no, you're wrong. It's not 88. That's Crooks. It's 87. So there's constellation number 87. And with that, I will all encourage you, even though it's smoky, get out there and observe.
Thank you, Jerry.
In my case, it's smoky all the time. My eyes aren't as good as they once were. And I often look at astrophotography as the answer. I still have to learn how to do some of it at Cherry Grove. But will photography cut through the smoke?
Does not.
It does not.
It causes just as many problems because the particles are illuminated by, light pollution.
The only thing that we have going for us in the summertime is that our evenings are short. So, it doesn't get dark until 11:15, used to be 11:30. My hope is that the especially it's the Canadian fires that are really are kind of throwing us off, and it is my hope that that they'll get things under control and we'll get our night skies back. But at least our homes and property are not burning. So God bless all those guys that are dealing with this in a much worse way than we are. We just have to deal with their smoke.
So does infrared cut through the smoke? I mean, what if we use a red filter or something like that? Would that help?
Still light, you're still looking, it's still photons, so yeah, it'd probably help, but it's not going to have the effect that you think it is. It's pollution. It's in the way. It's like a cloud. So it has the same effect as high humidity and dust and all those things. It has an adverse effect on our ability to see things in the sky. So
yeah, and I think you would need the kind of equipment that would be able to see well into the infrared range, which we can't. Our eyes can't much, and that's why they're building things like James Webb to be able to see into those frequency ranges.
So all the photomultiplier tubes we have, they don't do a good job with infrared?
No.
I don't know the answer to that question. I don't know. I know that those can do some pretty amazing things. The what are they called? Dale Eason has a great setup.
Jerry, maybe this way. I mean, it's not the sensor being sensitive to infrared or not being infrared. I mean, there's water vapor in the air that's going to cut through it basically absorbs most of the infrared. So a longer wavelength.
Great. Thanks for saying that, Dean.
Also, the glass absorbs the infrared as well. So.
All right, we need to move on. We need to get to our featured speaker. So here's just a reminder for you that the Astro League is online virtual this year, but you must register. And there are the dates, August 19th through the 21st. Check it out if that is your wish. And then the next thing is Astro League Awards. Jerry, I just left a slide in there just in case something came sneaking in at the last minute.
I ain't got none. A good thing, because I've taken way too much of our time today.
You're fine. You're fine. Get out there and observe. Thank you, Mike Shaw. Our next meeting, and it is going to be virtual. And I guess something that I did not add is that we are looking to find a venue for us to possibly go live face-to-face. October would be the earliest. What I think realistically is going to be November, and we could obviously be derailed, especially with all the things that I'm reading about, Wells Fargo and all these other companies that said they're going back to having their full offices, that they're pushing that off, later this year to be maybe even 2022. So hang on, we won't leave you out. We will let you know, but the board is working on finding a venue. So our featured speaker next month is Keith Olive from Minnesota Institute of Astrophysics. from the Big Bang until today, a brief history of the universe. I'm kind of excited about that. That sounds like a great topic. So with that, that takes us to our featured speaker tonight, Russ Durkee, our very own Russ Durkee from the Shed of Science, from the beautiful skies of stellar skies in the middle of Texas, the middle of nowhere, Texas. Russ, I'll quit sharing and turn it over to you.
All right, yeah. Let me see if I can get my screen shared here. Share that. All right. Actually, before I even do this, yeah, as Mark said, I am in Texas right now at my observatory. Actually, it's an observatory I share with our illustrious leader, Mark, and his telescope is here too, just a few feet away from me. Mine's behind me here, but I wanted to show you what, now I'm lost in, here, stop share, there we go. I want to share another tab. Here we go, let's see if this works. Can you see the live view out of the camera, or is it black?
No, it's black. It's the sun is setting and there's your car.
There it is, yeah. So this is what it looks like from our camera looking west in the middle of central Texas. You can see the sun is setting, and it actually looks on this camera better than it actually is right now. It's probably, at least even down here, I arrived on Wednesday, and there's been haze. It's not nearly as bad as Minnesota down here, I have to say. And it looks like we're going to have a nice clear night. So hopefully we'll be able to get a little astronomy done. Here's another image. Hopefully you can see the satellite image. I've got a dot here on my location. I'm right in the middle of Texas. If you kind of balance Texas on a pin, that's about where the location of this observatory is. And you can see we've got this lucky little clear slot here. And I think this line of clouds to the north and west is dissipating, but it remains to be seen yet. But it looks good out there now, right now. So let me share my presentation now, and I'll get started.
Look how beautiful Albuquerque is.
Yeah, let's see. Share screen. Here we go. Oops. All right. There we go. So the topic tonight that I would like to talk about is asteroid photometry and what I do here at the observatory. I've been a member of MAS since probably the mid-90s, I think. And I started doing imaging, in the early 2000s after doing astronomy mostly my whole life. And started doing asteroid photometry in earnest in about 2004. And will be my third observatory, I think. I built a couple in my backyard. And that eventually started a desire to move off-site and to have a remote observatory. And Mark was brave enough to join me in this venture back in 2018, I think, or 2019. We had set up the observatory here at a site near Pontotoc, Texas. And to give you an idea of what this looks like out here, we're out in the Texas Hill Country. And this is a view looking down the hill. We're kind of up on a ridge or a hill looking over a valley. Although you can't see the valley from here, it's surrounded by scrubby oaks and pinyon forests. But it's a lovely location. It is central Texas, so it's hot and a little more clear than Minnesota, but not by a huge margin. But it is very dry, and the seeing is quite good. Where are we located? This is, as you saw before, there's the map of Texas with a dot. We're about 2-hour drive from Austin. So on the map here, there's Austin. Houston is over here. This is all the light polluted eastern part of Texas. But as you get out in the hill country, it gets dark and the skies are nearly pristine. They're pretty darn good. On the Bortle scale, 1 to 2 for those of you who keep track of that sort of thing, which makes our skies somewhere pretty close to 22nd, 21.8, around 22. I forget the magnitude, what the units are there, which is pretty darn good. The site is hosted by a small company that was started by a small group of people who are from the Austin Astronomical Society and San Antonio Astronomical Society. This location sort of started as a private dark sky site, and they started renting out spaces or leasing spaces to members of that club. And then once everyone signed up who wanted to have a site for visual observing, they started opening it up to other people. And so in late 2018, I believe, the site came to my attention, and by the following year, we had our observatory built. And so there it is. There's a little shed here. It's a 12 by 16 foot roll off. So you can see some of these other observatories are quite large, and there's a large number of them. It's almost full right now. I think they could probably squeeze in 1 or 2 more. There's 2 more that have been built over on this left side, but it's pretty much full. And it's a great location. It's about as far out in the country that you can go and still get high-speed internet. And we just recently got fiber optics, so it's, couldn't be better. No real significant light domes. There's some sand mines off to our west that probably are the largest light pollution causes, but it's very minimal. About half of these observatories are run by remote people like myself and Mark, and they are run from people as far away as San Francisco and on the East Coast, West Coast, and some of us from Minnesota here. Here's just a picture of the observatory up close. It's 12 by 16. It's got 2 piers. Mark has a 130 millimeter refractor on a separate pier. And it's built pretty darn well. It's got, as you can see, for those of you who are observatory builders and have them your own, it's got a nice I-beam there, which really helps in Texas heat, because things like to warp, especially if they're made of wood in the brutal temperatures that we get here in Texas. This is hot off the presses. This happened just last Sunday here at Stellar Skies. That there is a unsecured roof on an observatory that is significantly larger than our observatory that came off last Sunday. Unfortunately, there was a downburst in our area, and at least 40 to maybe 60 mile-an-hour winds. It's kind of a guessing game how fast the winds were, but our weather indicator said about 40 miles per hour, which shouldn't have been enough to lift this roof off. However, this roof was not secured in. It was pretty lightweight, so it flipped off, damaged the neighboring observatory, and yeah, that guy is in San Francisco, and he's going to come out and have to work on rebuilding his observatory, unfortunately. So everyone, what's nice about a facility like this is everyone who was here pitched in and rescued his equipment. Nothing of enormous value was damaged as far as we know. The telescope mount was not touched. Things just got wet. And so things that got wet probably are not going to be doing too well. So yes, this sort of thing can happen. And so there we are. So moving on to our scope, the scope that I'm going to be talking about tonight, at least my scope. Here it is. It's a 20-inch plane wave, and this represents over 20 years. I've been observing and a serious astronomer for at least 30 years. And this is sort of the culmination of a lot of long-term investment in the hobby. It's a 20-inch plane wave. I bought everything used, I think, other than the mount, the camera. It's got a FLI camera. I'll talk about that a little more. It's got a 7-position filter wheel, finders and guiders, wide field electronic finders. And since this is a remote telescope, There's cameras everywhere, and I have electronic finders, wide field and narrow field finders, and high resolution encoders on the mount so that it virtually never gets lost, as long as you just let it do its thing. The only time this telescope really gets lost is when I make it get lost and start getting impatient and click buttons too fast. So it can run without being touched for, well, I don't know what the longest was. It was close to a year that I didn't touch it. And so that's the kind of reliability you have to have, though, for a remote setup. There are many fine features in this observatory. We've got art made by my lovely daughter. We like to call the observatory, we like to say it with an English accent in our house because it sounds fancier. We call it an observatory, like, you know, English-speaking people. And so she made this great little piece of art that has binoculars on it, so you can not only view the lovely art, but interact with it by removing the binoculars and going out and doing that. Of course, there's useful astronomy stuff like temperature gauges that remind us why we don't live in Texas all the time when it's 80 degrees this time of night. The terrifying insects, which seem to be everywhere in Texas. This is a scorpion that I squished during my last visit, and it was still stuck to the wall, and I removed it and took a picture of it here. Oh, and then observatories in Texas. It's funny how astronomers in different parts of the world do different things, but what they do here is you insulate the observatories like crazy to keep the heat out, and then you can air condition them, because at night it probably will get down to 80 degrees or 70 degrees and 100 during the day, and you can keep your observatory cool in the daytime so that it's ready to observe. And it actually works pretty darn well. And by using a remote control unit that's web enabled, you can control the air conditioner remotely. Remember, this is a remote observatory, and so basically everything has to have some web enabled device attached to it. So everything is chosen for that purpose. So a few years ago, Mark and I, or maybe it was last year, we talked about a lot of this stuff, but I'm just kind of quickly going through that. But what I really want to talk about is the science that I do here and how you actually pull this off and accomplish this. One of the biggest changes in the last year and a half is that I was able to get a new camera through a grant from the Planetary Society. They were kind enough to have a very long-running program called the Shoemaker NEO Grant Program. And through this program, if you do research on near-Earth asteroids, you can apply for money for equipment and upgrades. And I've utilized this service on 3 different occasions over the last 15, 20 years, and have managed to get 3 grants, and this was the latest and largest one, to replace an aging camera that I had from 2010. Now, the camera I had was the venerable ST10XME, and those of you who are camera geeks will remember this camera. It's basically, by today's standards, pretty low resolution, 3.2 megapixels, but it was super sensitive, and it peaked out at 80% quantum efficiency, meaning 80% of the photons that hit that camera were registered over a certain wavelength. And in its day, it was an amazingly sensitive camera. The problem is, over time, these things sort of lose their ability to function as well. You get dead columns, you get dead pixels. The heaters or the coolers have a tendency to not work as well. And once I moved it to Texas, it really could not cool most of the year. And so I suddenly, although I gained sensitivity by coming to a darker site, I lost sensitivity because the camera really couldn't cool very well in the heat of the summer. In the winter, it was pretty good. It worked pretty darn well. So last summer, I decided to apply for one of these grants again. Not really certain I would get it because the camera that I wanted was quite expensive. And so, but the new camera that I was able to purchase is extremely low noise, and it has over a 90% quantum efficiency. So that means I gained over 10% sensitivity and without changing the size of my telescope. So that's an amazing advantage over a much wider wavelength range, and it can cool down to levels that give it better noise control than the earlier camera. Now, the thing that is different about this camera kind of goes against a lot of what astrophotographers are looking for is this camera is still pretty low resolution. Now, there's a zoomed in picture there. The pixel scale is pretty rough by today's standards. It is what you would call, if you were a modern imager, a undersampled image. But what I really am looking for photometry is optimizing and reducing noise at all costs so that the signals I am trying to sense with the camera is maximized. And the way to do that is to have just enough pixels that cover a star, but not too many, because every single pixel will add noise to the image and it will reduce your ability to detect faint signals. So you try to size your pixels to the scene, and this is the pixel size I have is about 1.19 arc seconds per pixel. And in a 4-minute exposure, I can easily get a 100 signal to noise ratio and measure over 17th magnitude objects. And if you're a visual observer, you know, that's an enormous difference in sensitivity, because, you know, you might see Pluto or something that's quite faint. You might see 14th magnitude objects, I suppose, in a typical telescope. You know, we're 3 to 4 magnitudes greater, so whatever that would be, 2.5 to the 4th power, whatever that would be, times more sensitive. And it ends up being about 4 times or 3 times more sensitive than what I was getting with the earlier camera. All right, so that's for you imaging people. Yeah. So what am I doing here? And this is a different kind of imaging that people typically do in astronomy, amateur astronomers. I call myself an amateur astronomer. I also just call myself an astronomer. I call myself an unpaid astronomer because I think I sit squarely halfway between an amateur astronomer and a professional astronomer. I sometimes get a little money through grants, but I've spent a lot more money over the years out of pocket to do this stuff. And so I need to explain what I'm doing. Now, this talk was going to be about astrometry and photometry. Now, it's mostly going to be about photometry. I'll probably have to do another talk on astrometry sometime in the fall or something, because there's just not enough time. But astrometry is finding the positions of objects and also trying to determine orbits so you can figure out where these objects will be. Those are things like asteroids. And this is something I've dabbled with over the years, and I'm getting a greater interest in it because while I'm measuring the brightness of objects, which is the photometry, I can at the same time look for objects that need measurements of their positions in the background. And so it's something that I'm starting to do sort of as an additional bit of science. So photometry is what I'm doing. That is figuring out how bright something is. And you might think that's pretty easy. You can look at an object and say, oh, that looks twice as bright as something else. But actually getting a precise or accurate measurement is really, really hard. The kind of software that we're using, these might be things you've heard of before. Astrometrica, the one in the middle, is probably the most well-known of these. Astrometrica measures positions of objects. It's the most widely used asteroid following software out there, and it's a bargain at $30. Tycho Tracker will do astrometry like crazy, and basic photometry is changing really rapidly. Super great piece of software if you're just getting into astrometry. It does this thing called synthetic tracking, where it will search for moving objects in your images, in a series of images, unlike any other software before. It'll explore tens of thousands of possible vectors for motion of objects in the background and evaluate whether or not they're real detections in the background. It's an amazing piece of software. The software that I've been using for the last almost 20 years is MPO Canopus. It does both. It does astrometry and photometry, and it's the most widely used asteroid photometry software out there. If we get enough time here, I'm going to give you a little walkthrough of how it works.
Is it able to differentiate between like satellites and asteroids?
The Tycho tracker probably can do that. SkyX could probably do that, probably easier. But Tycho tracker will do that.
Okay.
Canopus will not. Astrometrica, I'm not certain. Photometry. So how bright is that thing? You might think that this is pretty easy. Now, there's a little math here, but just hold on, it's not too hard. Here we go. So let's say you want to figure out the magnitude of an object, all right? The way that photometry is generally done is you compare the object of interest, like an asteroid, to a comparison star in the field of view that has a known brightness. And you might think, oh, well, that's easy. We'll just compare it to this other star and then look at the difference and then just add or subtract that difference to the comparison star. Done. Easy, no problem. Well, the problem is it's way more difficult than that. That would be great and that would work really well if you looked at a star field, a random star field in the sky, and you knew exactly the brightness of all the stars. And we don't have super reliable catalogs for every part of the sky. We have catalogs, all kinds of them, but they're riddled with all sorts of problems. Now, there is a brand new catalog out there, the Atlas catalog, that is the best one out there right now. It's still not perfect, but it's getting better. You might think, oh, great, now we can use that. No, it's not that easy because there are unknown variable stars in the mix. And so what you do to fix that is you take the average of multiple stars in the field of view and you calculate the average brightness and you find the difference in brightness between your object and the average one. And this is basically what I do. It's not calibrated photometry. This is what's called differential photometry. I'm finding the difference in brightness between an object and objects in the field of view. Why isn't this perfect photometry? Because it's not calibrated, because it's not on a standard system. And the difference is that basically I'm only doing this and I'm only getting differences, and from night to night there will be differences because the catalogs will be different. The object will be in a different part of the sky, and it does not take into account things like color. It doesn't take into account extinction, which is the brightness change of an object as it goes from a low altitude to a high altitude. It'll get dimmer at the horizon and brighter when it's straight up. And there's something called second order extinction, which is just this thing that we just saw in the picture of the sunset. When an object is low on the horizon, it looks a lot redder. And when an object is high in the sky, it'll look less red. And blue objects and red objects are going to change differently as they go up into the sky. And so if you have comparison stars of different colors, they're not going to have the same offsets. They're not going to have the same differences. And in order to do that, in order to calibrate all that perfectly, is extraordinarily challenging, and it's hard to do from an amateur site. But it is something that I'm starting to do a little more of. What are the benefits of doing it this way? Even though it's just on an internal system, you actually get high precision doing it this way, meaning you can measure the differences really precisely. It's just not accurate, meaning you're not very close to a known value. But as long as I'm only doing it myself, I can get a pretty good comparison to the night before. It's fast to do data this way. The tricks to make this work is you got to have all night long runs of data to do this. So I'm taking pictures all night long, thousands of pictures sometimes. And the other trick is I have software that allows me to choose comparison stars that will minimize all of these errors. All right. Right, so how do you actually do this in practice? Okay, so here's the image. Here's an example. So one of the things that you may or may not have noticed or known, especially if you're an imager, imagers are aware of this, but maybe people who are visual observers might not be aware of this, but all stars are the same apparent diameter across when you look at them in the sky. Yeah, some are brighter and some are dimmer, but if you look at their profiles on a CCD, they're going to have the same little shape, this Gaussian shape, this up and down shape, and they'll have the same width due to the seeing in the sky. And so when you're doing photometry, what you do is you basically put a measuring circle. There's a measuring circle down here we call the aperture, and we put it over the star, and you measure the width of the stars. And no matter if I touch one of these bright objects, the big stars, or the little stars, which are dimmer, they're going to have the same diameter. They're just not going to have the same total flux. They won't go up as high. And so you can choose a measuring aperture that encloses all of this light that's falling on those pixels, because this represents all of the photons that are received in the silicon, and they're all adding up on our pixels. And so we set up that measuring aperture so it's right encompassing all the way, almost all of these tails of this data. That is going to be all added up. All of those numbers corresponding to the object, the background, the sky, anything else that happens to be in the background will be added up inside that measuring aperture. Then, ideally, you want to just measure what the star or the object is, the brightness of the object. So you also measure the sky. So I have an outer ring called the sky annulus, and you measure the average brightness of the sky pixels. And then you count the number of sky pixels in here and you subtract that, because even though there's signal there, there's sky noise in there as well. If you live in light polluted areas, there's light pollution noise in there, which is super duper noisy. From my experience of running observatories within Minneapolis, light pollution is a super noisy signal. And you know, if you're an imager, you have to filter that out some way. So you do this, you add up all of that inside, all of the value inside the measuring aperture. You do the same with the comparison stars, and you find the difference. So here is all of our comparison stars. My asteroid in this particular image is in this yellow box. There's a zoomed in image of the asteroid. And you can see my comparison stars. And there's a little tool in Canopus that allows you to pick the best comparison stars for the asteroid. What there are is stars that happen to be kind of red, because asteroids are rather red. They reflect starlight, so they're mostly G stars. So stars like our sun. And those are really the best comparison stars for asteroid work. So I look for ones that don't have background stars, that aren't doubles, and that look pretty close to the asteroid. And those become my comparison stars. And I take the average brightness of all of those and I compare it to the brightness of the asteroid. And I do that over and over and over all night long. And remember, what's extra tricky about this is asteroids are moving. So this object is not like a star. This thing moves throughout the night. And depending if it's a near-Earth object or a main belt object, these things might be moving many arc minutes per minute. So sometimes you have many across many fields, and then things get rather tricky to process. All right, so what do? You get all this data, you graph it. Of course, you want to see the brightness of these objects. So here's a graph. We've got magnitude on the left. Just ignore the negative and positive bit. It's just brightness up and down. Time is on the lower axis. And you can see each one of these data points represents a single image and a single measurement of brightness compared to comparison stars. And you can see there's a regular pattern here. We've got an up, down, up, down pattern on this asteroid. Generally, the way you interpret these is they get, let's assume that this is the brightest bit up here at the top, because I always like the topographs to be brighter. And so it gets brighter because the broadside of the elongated asteroid is facing the camera. Then the narrow side becomes visible, and then the broadside, then the narrow side, and then the broadside, and then the narrow side. And you can see this pretty regular period moving throughout the night. And you might look at this and go, hey, that looks pretty good. Great, we got this asteroid rotation. You can measure this rotation rate. You can get some idea of its shape based on the shape of the asteroid rotation rate. You can publish this result in a journal. And this is kind of the thrill of the hunt for me, because a lot of times the asteroid rotation rates are not ever measured. So you get to do something first, you get to sometimes discover interesting things about these asteroids. And this is a perfect example from, this was February of this year. So you look at this and you think, oh, okay, there's a regular period here. If you take those observations and fold them over, and back in the old days, astronomers would plot these manually on tracing paper and then overlay them and try to figure out whether or not there was a regular pattern here. You'll often find this bimodal period that repeats over and over and over. And in this case, this object has a bimodal period. So basically you're seeing one side of the asteroid here where it's bright, one pole, or not pole, narrow side of the asteroid, the other broad side presents itself, and then the other pole or the other narrow side presents itself. And this is pretty typical for an average asteroid. Not all of them are like this. You can get all kinds of patterns depending on the shape of the asteroid. Sometimes you get tumbling objects that rotate on two axes. Sometimes you get really slow rotators. Sometimes you have hundreds and hundreds of hours. Other times you get fast rotators like this one. This one has an hour rotation of 2.59 hours, which is near what we will call the Rebel pile limit. We'll talk about that in a moment. So you might think, oh, we're done. Let's publish this thing. Let's move on to another object. We got double coverage on it. Looks good. Not. And then you observe it one more night, and this happens. You see something different in this curve. Anyone? You look at it, and it starts out pretty much the same curve. It goes up, down, up, down, up, down, up, and then, like the stock market, it has a lower peak and then a crash down here, and all of a sudden down at the bottom here, and then it comes back up and it kind of goes back into the same pattern. What in the world is going on here? And this is the kind of thing that I started doing right away, early on, when I started doing asteroid photometry. This is a shadow transit or an eclipse of a second object in the asteroid system. This is an indicator of a second object being present somewhere around or near this asteroid. Now, you can't necessarily tell whether it's a shadow transit, or maybe there's a large crater on the thing, or maybe there's a moon around the asteroid that's casting a shadow or eclipsing. So in order to figure that out, you really need to study this thing over very long periods, and it usually takes many, many people to do that kind of work. So this is something that I've been doing pretty much continuously for the last 15 years or so. So here's the same curve, 2.59 hours, and there's that weird dip. You can see it sort of follows the other curve. It's just that there's this offset, and then it regains the other curve. So the question becomes, how often does this happen, and what can you learn about that? Can you figure out the orbital period and try to identify, is there an orbital period for the second object that may or may not be here? So you have to observe this over many, many, many nights. And so I'm a part of a group of astronomers that are based around in the Czech Republic that have observatories all around the world that set up campaigns on objects like this. And this is just an example of 8 nights of work over a month. And this is not the only data for this project. This was just the data that I took for this object. And you can see over time, this has illustrated a number of really interesting little dips in the data. So there's something really complex going on in this light curve. So can you tease out what's really happening? And thanks to software, yeah, you can. Now, what you can do is you can take that first 2.59 hour period and separate that out, take that away. So I can subtract out that 2.59 hour period and see what's left. And when you do that and you solve for that period, you end up with something like this. So what we have here is there is a 37.14 hour signal on top of this other 2.59 hour signal. And here you can see an eclipse. It looks like there's this dip at about 0.25 phase here. Nothing. This means just the regular 2.5 hour period. And then another shadow transit, probably when this object passes behind the main object. So this would be an eclipse signal at first, and then not a transit, but a passing behind signal, an eclipsing signal of the secondary object here at 0.75 phase. So each of these different colors of dots represents a single night of data from a different station, probably from around the world. I know it was me and 4 other stations that contributed to this data. And this was published in, as an announcement. We published these through what were once called astronomical telegrams. Now, of course, they're emails. And as a call to other observers to study the object. And so here's just an example of one of those things. So here's this object, 3390 Deminet. And so you get this little attaboy kind of publication. These are the same publications that go out for things like comets or asteroids that are potential impactors and things like that. And then later on, we publish more complete data. So any questions before I move on to the demo of how to actually physically do this?
Well, it seems like the data is ripe for an FFT analysis. Have you done anything like that?
Yeah, that's the main way we do it. The FFT is built right into the software, and so that's basically what we do. You have all this data out here. You run the Fourier analysis on the thing, and it gives you suggested periods, and then you can filter through the periods and see which ones look most plausible. And sometimes it's really tricky because you have to interpret that data and try to figure out which one actually is probably the most likely. And sometimes you end up with a couple of possibilities. So yeah, that's exactly the tool we use for all of this stuff. All right. Oh.
Question?
Yeah.
With your camera cooling itself so well in Texas, do you have problems with condensation?
Good question. This particular camera, this FLI camera has, ironically, it's got a heater on it too to deal with that. The camera cools down. It's got the typical heat sink machinery on the back end, and then on the front end where the cover slip is, it actually has a dew heater that heats the cover slip so that it doesn't fog up when it's super humid. So yeah, I think all of that engineering is part of the reason these things are so god awful expensive. All right, let me just give you a taste of what this is like. We've got a few minutes here. So here's an image. Hopefully you can see this image. And I'm not sure how the animation is going to work here, but here are 2 images of that very object. And what's neat about this particular image is not only can you see the asteroid jumping back and forth down there in the lower third of the image, but there's a ton of background galaxies.
I don't think I'm seeing it.
We're only seeing your software or your presentation software.
Okay.
PowerPoint.
Let me stop the share and I'll share the other one. Bump, ba-dum, bump. Here we go. Thank you. All right. So hopefully you can see the image. Can you see it?
Yep, there you go.
Okay. So the asteroid is right down here, but look at this image. This is, the stars are rather blobby. I would say the seeing is not so great here on this particular night. But look at all the galaxies. I mean, there's galaxies everywhere. It's a 20-inch scope, so it pulls in background stuff like crazy. Galaxies. There must be dozens of them all over the place in this image. And our little asteroid, let me hit the start button to blink this image, is right here. I'm not sure if the animation's coming through very well, but there it is jumping back and forth.
Very
and
good.
So you have to use this in order to just verify that you actually have the asteroid in the image. There's a second asteroid in this picture too. Down here, right here, there's a nice little guy jumping back and forth. And so these are the sort of things that I want to do astrometry on, because a lot of times there's asteroids hiding in the background with these, but it is a rather narrow field of view. It's 20 arc minutes on a side, so it's not super common. There's not like dozens of asteroids in the background, but every other night there's background asteroids, probably.
You ever get the urge to do a Shed of Science deep field?
Shed of Science what?
Deep field, like Hubble?
Yeah, I know. The time, though, I mean, the time involved. There's so much stuff to do. Yes, send me a location, RA and DEC, and we'll do one. All right, so, but I'm not going to spend 20 hours on it, right? Let's see. Let me go over to, I'll measure just a quick session here. I want to make sure I got the object. So I got this object here. I'm going to go through just a couple of little things here to get started, to get to the interesting stuff. All right, so let's do a light curve. Oh, I didn't do that, so let's do this. Open this up. Yep, 3390. I'm just going to open up the star. So there's an image. I want to make sure that I have a plate solve on the image, meaning so that it matches a star field. So there it is. It's identified all of those stars in the field. It has also identified the asteroid, but it's not turned on, and there's an asteroid there. Let's do a light curve. It's asked me to open up the first image in the set. You'd think I already did this, but there it is. Here, let me get rid of the screen. All right, so here it is. I want to open up a few images here. I'm going to have a zoom in window. Let's open up a star profile so we can look at the stars. So remember when I said that all the stars are the same size, even though they look small and one looks big? Here, I'll prove it to you. So here, I'll go over here. Here's kind of a little, there's a littleish star, dim star. There it is. You can see the little Gaussian there. It's about 5 pixels, about 10 pixels across. Let's go to one of these big blobby ones. Bang, 10 pixels across. You can see that one's saturated. It has a flat top. All of them are, give or take, 10 pixels across. Doesn't matter. Unless I go to one of these galaxies here, maybe that one will show up as bigger. Oh yeah, there's a galaxy. So pretty neat. Okay, so let's just try to use that information. I'm going to shrink my sky annulus here just a little bit. 5. This is where I'm setting my sky annulus and my measuring annulus. Let's go through and measure a couple of frames, and I'll show you how you build a light curve. So first I want to select my target. I want to make sure I got the right one. This is where I go back here and look at that and say, oh, okay, so there's these 3 stars, there's a galaxy, and the asteroid's right below it. 3 stars, galaxy, asteroid's right below it. Okay, so there's my asteroid. I center it, I click on it. That's my target. All right, so I want to select stars that are solar stars, and I want them to highlight the ones in the image that are solar-like. I'm not going to get into the details about how this selector works, but I'm just going to select a couple of stars here. Oh, that one looks good. I'm looking, there's signal to noise, looks okay. I'm not going to be super careful. I'm going to set that as my comp star 1. I'm going to go over to this one, even though there's a background star, but it'll be okay just for demonstration purposes. Comp star 2, and then maybe we'll take this one up here, even though there's another background star. Comp star 3. Okay. Now, because I'm doing this, the software isn't super user-friendly. I have to do a couple of button presses. All right. Now I've got those selected. Let's see, I got to remember, I don't remember which one I chose now here. 692 and 407. Okay, that one. All right, now I have to go and select the second one in the set. So I got to write this down so I don't forget. I'm going to go through the one that is 096, ends at 096. Okay. The second one will be this one here, even though there's a lot more, just for, since time is of the essence. And it comes up here and it'll label the comp stars, and assuming the asteroid hasn't moved too much, it should label the stars correctly. Most of the time it does not do that very well because the asteroid moves and my telescope follows the asteroid. There's a little guessing and practice here. My mouse is working. Okay, so now I only have to select comp star 1 and it knows where the other stars are because the offsets will be the same. My target is now moved a little bit. It's over here, so I'm going to select, come on, mouse. I'll have to do it with the pad here. All right, click, hit the target button there. That one's now selected. I hit next. I have to save my comp stars because it saves an image of your comp stars. So when you forget which ones they were, you can go back and open that up and figure it out later. Okay. So now it asks me, okay, let's measure all of our stars. It goes to 096. Here we go. I'm going to select these images for my truncated data set. And now this is where the fun begins. So here is where I'm going to actually do the photometry. You can set this up to do it all automatically, but you know, it's garbage in, garbage out. I like to look at every single data point and make a judgment call about whether it's good. I want to know if there's a background star entering my sky annulus, because if you happen to get a background star that enters into your measuring annulus or the sky annulus, it can foul up your data, and in some circumstances it might look like a binary asteroid signature. Most of the time it doesn't. It gets brighter instead of dimmer, so they're usually easy to pick out, but not always. This is the thing to look at. That's your object. That one looks good to me. I hit accept. It goes on to the next one. And hopefully it follows the asteroid. I don't see any hot pixels. I don't see any background stars. Nope. That one looks good. That one looks good. You'll notice the telescope tracks pretty well. That's one of the hardest things to do. And if you've ever looked at images through professional telescopes, you'll see that they put up with a lot of bad tracking, especially the older telescopes. That's one of the nice things about having an amateur setup, is that you can be in control of how well everything runs. Here's a satellite going through, and you might ask the question about Starlink satellites, and yeah, they're starting to show up everywhere in my images, even in my 20 arc-minute wide images, but so far they're not a huge problem. So I'm continue going. Good, 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 good.
I got a quick question for you.
You bet.
You said that the telescope, the mount, is actually tracking the asteroid itself.
Yeah.
So I assume then that there's some sort of catalog that's within the software for the mount that allows you to select to track against the asteroid as opposed to just the stellar tracking.
Yeah, so it's not actually, I may have misspoke, it's not actually in real time tracking the asteroid, so I'm not getting blurred star images. But what it is doing is I have a script running so that every so many images it updates the pointing of the telescope.
Oh, to keep the asteroid in your field of view. Okay.
Yeah, in the center of the field is where I usually
Gotcha.
So
Okay.
it depends on it depends how fast it's moving. And so like the other day I was measuring one that was moving, you know, maybe a fifth of the width of the screen in 5 minutes, which was pretty fast. It was a near Earth object. And that one I had to update every image in order to keep up with it. And that complicates things because then you might have multiple groups of comp stars. So you have to kind of piece together a light curve with different groups of comp stars, and it makes it really complicated. All right, so I did all my measurements. I got to go back to this session window now and click a magic button to calculate an offset. And then now I've got all of my observations here in this nice graph, or not a graph, in this table. But the neat thing is actually looking. So I can even look at my comparison stars. There's the light curve of the comparison stars. And they should all be flat because you want your comparison stars to be not changing in brightness. And on about 3 occasions in the last decade, I've discovered new variable stars this way. And then you compare them to each other, and they should also be a flat line. So these are the average comparison star value. All right, so now that all looks good. Now let's look at the graph. Oops, I have to hit OK over here, otherwise it complains. I go to the graph, I hit find. Oops, I want to do raw. And you can see someone asked earlier about the Fourier analysis. There's the magic button right there. All right, I select tonight's data set, I hit OK. Okay, here, let me just ignore that. And you can see there's our light curve. You can see I only measured, we only measured those few images, but there is each image resulted in a singular measurement. I can bin the data if I want. If I want to turn one data point into 2, I can do that, and it'll average those out. There we go. Okay. I still have my there. Oops. There's the raw plot, so I can do things like that for you mathematical people. I can calculate do a Fourier transform on it. Let me put only 2 in order 2 on there.
I've got a couple of questions. So your comparison stars, do they have to remain in the field of view while you're taking data? So in other words, if you're following an asteroid and it moves and it moves such that your comparison stars fall out of the field of view, do you have to choose new comparison stars?
Yes.
So if you're doing an all-night run, then you have to get up periodically and choose new ones, or can you choose them ahead of time?
No, I don't even do that. I just let the asteroid go. I follow it all night long, and I worry about the details the next day.
Gotcha. Okay.
So yeah, hopefully it doesn't do that, because that complicates the processing like crazy, because now you've got many smaller bits of light curves that you have to piece together. And with different comparison stars, there's going to be offsets in the graph. So the graph will go along nicely, and then suddenly it'll drop or go up a magnitude or something, and you have to manually adjust those offsets. That's where the fully calibrated photometry would be useful.
Yeah.
And it's something that I'm exploring and trying to learn more about.
I bet.
But okay, so as we finish up here, let me go back to my presentation and wrap it up. So you might wonder, well, what do you do with this data? Well, here's something that has come from this research in the last 20 years, something called the Yorp effect. I'm not going to try to pronounce those words, those Eastern European names, other than Paddock.
Russ, you're not sharing your screen.
Oh, I thought I shared the right one. Share screen. This one. Share. How's that?
It says it started, but it hasn't happened.
All right, let me try this. Does that work?
There you go.
Okay, so this effect is basically it's light pressure momentum transfer due to light impacting these oddly shaped objects, or thermal re-radiation of these photons. each of those photons either impacting the object or re-radiating off the object can impart tiny, tiny bits of momentum and change the rotation rates of these objects over time. And we've measured this in asteroids and in binary pairs. So it's a measurable effect. It's small. But the thought is that this is the cause for asteroids to fragment over time, because these oddly shaped asteroids are spinning up due to this light pressure and turning themselves into binary asteroids or trinary asteroids. And so you end up with a graph like this. If I graph frequency on the left versus diameter on the bottom, you can see it's not a random distribution. Right at 2.3 hours, right here, there's this wall. This is called the spin barrier, and that happens to be the speed at which an asteroid can spin, and it begins to break up. So this is where you get the preponderance of binary asteroids. And every red triangle there is a binary asteroid. You can also see these fast spinning ones in the upper left side of the graph. Those are solid objects that are spinning very rapid, and they tend to be smaller. It makes sense that if you're going to have a solid object, they're going to be less likely to be gigantic. So when you talk about asteroids coming in and impacting Earth, you probably want to know this kind of information. And so over the last 15 years, I've watched this graph fill itself out and kind of reveal these truths about asteroids, and especially binary asteroids. As I end up, Planetary Society funds people like me, amateurs and professionals all over the globe. Please consider joining and donating to them. They're a fantastic group, and they've been very kind to me. And if you don't do that, that's fine. But check out Planetary Radio. I've been on it twice now, and they're so nice. They make me sound smarter than I am, and so I really appreciate that. So that's my little plug for the Planetary Society, and I'll end it there. Thank you, everybody.
Any questions from anybody? Hey, Russ, thank you very much for coming on tonight.
Oh,
and
absolutely.
Sharing what you're doing, sharing what you've done. You know, I know I've gotten a peek of it as you've been going along, but you know, it's always nice for you to share. It's
great. My pleasure.
I think everybody enjoys it. Thank you.
You're welcome.
All right, thank you, Russ.
Thank you.
Good night, everyone. See you next month. And most likely we will be live from NNSF. Take care. Have a good month.
You too.